So here we are with the ICOM IC736, and it's not working too well on 6 meters. It sounds pretty dead. And I was looking through the service manual here, and I saw that C39 is to be adjusted for the right voltage in the PLL loop. And we weren't getting the right voltage on the test point there, J5. And I just put this screwdriver in here. That's all I did. And I touched the screwdriver to the pot to adjust it. As soon as I pressed on it, it came back to life. See that? So perhaps all I need to do is resolder that or replace that part. Okay, so I got the Marconi turned on as a SIG generator. It's connected into the back of the radio. And with my screwdriver on here, in just the right spot, well, there it is. It does receive. It's 1 microvolt. It's not great, but it's getting there. So maybe some cold solder joints, maybe a bad component. We'll see. One more observation real quick. I'm looking at the lockup voltage here. That's the voltage driving the varactor diodes. And the way this PLL works, it sends DC to those diodes until it reaches the frequency it's supposed to reach, and it kind of levels out there. This one, when it is enabled here, locking at 1.4 volts. So that's outside of its range. It's really supposed to be around 4 volts, I think, maybe 6 volts or so. And that indicates that this circuit's really out of tune. That's what that tells me. There it is again. And when it unlocks, you'll see it just climb way up until it reaches about 8 volts or so, and it kind of gives up there. So that's that lockup voltage right there. These are tuned circuits for each of the 5 bands the radio actually has in its PLL, different than the multiple bands supported on here. Some of them use the same tuned circuits. And so we're going to check the solder joints on here. Probably the component's just bad. And maybe look around for some other problems that could be here. Okay, so here we have the PLL board, and I've removed the cover. You can see the insides here. And this clip lead is on the lockup voltage. That shows the voltage going to the varactor, which is the diode that changes capacitance and creates the VCO. And the problem we have here, try to zoom in a little bit, is that this variable capacitor right here, the C39 I believe, it seems to only work when I put pressure on it. And when there's no pressure on it, it's not clear to me if it's an open circuit or a closed circuit. But what we're going to do is remove it first of all. So let's see if we can get that part out without removing this cover, because that's not going to be easy, without taking the board out. It's a surface mount part. Heat it up, bend it a little bit, break off the back, pop it out. Let's see what we can do here. Well, an interesting thing happened as I was looking at this. This stuff over here, which I thought was some kind of potting compound, it seems to be paraffin wax, common candle wax basically. And as I was soldering here, this just melted right over what I was working on. So that's going to be fun. I got the part up on one side, and I'm probably just going to break off the other side because I don't really care. The other side is a large ground pour. It'll be hard to solder it in here. Plus I don't want to melt it anymore. Right out. There it is. Alright, so with the part removed, no variable capacitor in it, turn it on here. And it doesn't seem to lock. If I change bands, say we go over to 14, I've got a lock. That's locking at 5.9 volts. If we go to 6 meters, oh, there it goes. So now we're locking at 1.4 volts. So that's right at the bottom end of the range. So that's why they want a capacitor on here, because it just barely has enough range to lock at this voltage. Let me show you the lock-in meter here. There we go. So 1.403 volts. As I tune, you see it changing. You can observe the voltage changing up here. This is at 50.256, and we're at 1.415 volts. And if we go up to, say, I don't know, 50.4, now we're at 1.447. So the circuit is working properly. It just doesn't have a lot of range. And apparently when it starts up, it comes up on the wrong side of the bed, so it doesn't work. So we're going to add a little bit of capacitance there and help it out. Just a couple picofarads is all it's going to take. I thought, where could I get a little capacitor from without having to order one? And I remembered I have this. This is an old Midland business band radio that somebody gave me. And thank you, Scott Nolte. It's missing the crystals. There are no crystals in here. And you know, $20 a crystal, and you need 2 for each channel, 1 for transmit, 1 for receive. It's not economical to put crystals in here. But this is a great radio to learn about and to make things with and to reuse the parts. And here we go. Right here. Variable capacitors. Probably in the 5 to 20 picofarad range. There's one side. There's the other. So that might just do it. Okay, so here we have our MFJ meter. We're going to use this to read the capacitor. Now it's set up right now for capacitance. I've got it dialed in at 23 megahertz. It's reading 13 puffs from this little piece of wire here. Taking out the wire, lowered it to 12 puffs, so the wire is actually about 1 picofarad, and the rest comes from the internal circuitry. I don't think there's a way to zero it, so we'll just remember we started with 13. We'll add this and we'll whittle it around and see what we get. If you want to learn the fine art of soldering, probably should watch somebody else. I'm trying here though. Okay. So we got to 19. That's 19 puff. So from 13 to 19, we just gained 6 picofarads. It's actually close to what we're looking for because we want a 6 picofarad variable. Now, what happens if we give it a little twist? We're at 19 now. $14. Oh, don't go to sleep. No. Okay, 14. Still 14. That feels like the end of the travel right there. Turn it around the other way. 20. 27. I saw 27, but that could be my fingers. 14. So it looks like we're going from like 14 to 20. So, you know, 5 picofarads or so. Maybe 7. It should be on the order of what we need in the other circuit. So I think the thing to try now is to solder that into the circuit. And we may do it first with the wires, just to kind of see what happens. Okay, so with some difficulty, I got the variable cap soldered in here. And it was not easy because every time I tried to solder it, the wax just flowed right over the solder joints. However, it's there, so let's give it a test. Got the multimeter here set up to look at the varactor voltage. I'm going to power it on and see what we get. Eight volts. That's too high. It's probably not happy there. It's not varying with frequency, so that's not really good. Other bands. Not this one. Okay. But, you know, maybe a little adjustment here will help. Five volts. That's very close to where it's supposed to be. I actually don't know what it's supposed to be now, come to think of it. Let's see. Lockup voltage. .5 volts is our target here. This is dropping. So let's turn it the other way. Still dropping. How about the other way? Eight volts. Somewhere in between. And we're going for 6.5, so 6.8 is pretty close. If I turn this knob, haven't turned it yet. The calibration frequency was 60 megahertz, actually. That's where they cal it. Okay. Frequency input 60.0, enter. Okay. 6.8, 6.9. Let's put a tone on. 60 megahertz. That might help things out a bit. So 60 megahertz, 1 microvolt with modulation. That should come out just fine. What is that? That's receiving. The transmitter's FM, so we expect it to not sound too good on sideband. Okay, but it's there. Why did it take that sudden little unhappiness when I adjusted it? I don't know. Other way. There, it's off again. So pull it back down. 2.7 volts, so it's got a little margin. Let's see how it's receiving. 50.113. That's 2 microvolts in, and getting about S2. Let's see how low we can go and still hear it. That's 0.27 microvolts. 0.23 microvolts. We're down pretty low. Maybe that's not bad for our first cut. So I took the original part right here and the salvaged part, and I just bent the legs under it so they would have this similar spacing to the surface mount part. I'm going to try to put it in the radio. Well, it took some really careful soldering. And I mean careful, because this wax just kept melting into the solder point every time. The only way to do it was to build a huge glob of solder on here and really spike it up like you're not supposed to, and then carefully get that variable capacitor on there. Once I did that, boom, turned it on and it was almost perfectly aligned. A tiny change of the screwdriver here, and we're at 6.5 volts at 60 megahertz like we're supposed to be. So I would call that a success. And look at that, down at 50.1, that's what we're tuned in here on the display. 3.3 volts. So we've got plenty of headroom on the varactor circuit to work the whole 6 meter band. So that's really good. And here's how the circuit ended up looking. You can see the part. Oh, you can see the part right in there. I bent the leg so it would reach the solder pads. A bit hard to see. Yeah. There it is. And it's working. And of course, wouldn't you know it, a few minutes later, the sensitivity's gone. I'm guessing the capacitor fell out because it's not picking up anything at 60 meters. It won't transmit. It's hardly got any noise at all. Time to take it apart again. Well, I think I figured out the problem. There was a lot of wax getting into the solder, and so I propped up the radio using this otherwise worthless textbook and resoldered it, and that seems to have fixed the problem. It's working very well right now. So fingers crossed that the solder joints are good and it works when it's right side up too. I've been working on this for several days now, and it continues to be a problem. It works and then it doesn't work, and it works and it doesn't work, and it drives me crazy. I don't know what the problem is. I think maybe it's the JFET, because it's very sensitive and it kind of stays in one state and then it goes to another, but I don't really know. And for my own sanity, I screwed the cover on. I'm going to leave it on for a few days and think about it, and we'll just come back to this later. I think that's the only way I'm going to figure this one out. So stay tuned for part 4, the PLL part 2. 7-3.